Hello, everyone. My name is Robert Huntoon, and this is my course project. Um, so I was tasked with, or my course project is to evaluate credit card travel rewards redemptions for credit card company. So first thing we were tasked with was an opportunity evaluation. So this is my introduction and problem statement. Um, my team and I were working to improve our existing credit cards travel rewards engine that allows users to redeem credit card reward points for travel options. These options include airfare, hotels, and other destinations and vacation options. And the current credit card travel reward system has limitations that reduce its effectiveness and customer satisfaction. Um, Users struggle to find relevant travel recommendations that align with their preferences, potentially miss out on optimal redemptions due to fluctuating airline and hotel prices, and they have difficulty maximizing rewards because of complex point systems and restrictions that could result in receiving generic offers rather than personalized real-time travel suggestions. So, um, this is um, an opportunity or an attractive opportunity for a machine learning approach um, based on the solution because or a machine learning based solution because it significantly enhances the travel rewards experience um, by personalizing recommendations based on spending history, past trips, and real time behavior, optimizing reward redemptions to ensure customers get the best value for their points, and adapting dynamically to pricing and availability so that our users can receive up to date travel options. This also while increasing our user engagement by delivering relevant offers that encourage more bookings as well. So next we were tasked with using the CRISP DM understanding and business understanding and be able to explain that and define the problem. So our goal is to build a machine learning system that resolves the issue of inadequate travel recommendations caused by pricing volatility, evolving trends, and fraud. So the current travel reward system, like I mentioned, lacks personalized recommendations and dynamic pricing adjustments that have led to lower customer engagement and the presentation of irrelevant reward redemptions and missed revenue opportunities, really. Um, so success would look like leveraging the machine learning approach to create a personalized travel recommendation system that dynamically adjusts to the user preferences, their spending behavior, and real-time pricing. So some outcome metrics that I've outlined here, increase travel reward redemption rates or travel bookings via credit card travel rewards, a higher redemption of travel reward points, improved customer satisfaction, um, and improved net promoter score, increased engagement through the travel reward sites, and an increase of total transaction volume from travel purchases. Output metrics here, we have a model accuracy and precision in predicting user preferred destinations, so recommendation relevance, um, percentage of travel redemptions based on recommendations, like I mentioned, conversion rate on recommended offers, prediction accuracy, and response time. So this could be some output metrics there. Um, so one way to gather all this information really is to consult travel industry experts on pricing and booking behavior, work with credit card reward specialists for point redemption strategies, and engage with customer experience teams to identify pain points. So relevant factors to consider user spending behavior. So user spending habits, destination preferences, and redemption patterns, past travel history, seasonal travel, pricing changes, and limited time offers or sales on travel, reward points, balance and expiration, incentivizing timely redemptions, market trends, seasonality, like I mentioned, and a risk of fraud from credit card reward exploitation would be another factor to consider. And also, we want to be able to consider real-time pricing and availability. So making sure that we're able to have that information and data in real time to be able to present that to the user. Next, we were tasked with how to validate our plan, so solution validation plan. So first came up with design decisions. Our solution concept, machine learning analyzes user transaction data so that we can help identify top destinations based on previous travel and spending trends, better recommendations, efficient reward travel options so that they're able to really have improved and efficient reward options so that they're in line with their reward numbers and points, and to better adapt to seasonal and market trends for enhanced personalization. So um, really, what we wanted to do was propose a machine learning-based recommendation system that personalized travel and redemption suggestions based on user behavior and preferences. And machine learning will be used for personalized travel recommendations using supervised learning, analyzing user spend history, past travel, and reward redemptions to predict preferred destinations. Um, and dynamic pricing and availability, like I mentioned, will be utilized with real-time data feeds to update recommendations based on current flights, for instance, hotel pricing through reinforcement learning. So that'll be able to maximize reward redemption value. Also, predictive analytics ensures that identifies users that are at risk of not redeeming rewards and offers, and can give timely recommendations as well through or based on user interactions. So, solution validation plan again here, we have iterative experimentation experiments that we want to do. Um, we want to execute a series of iterative experiments to validate the solution, define the baseline, define a baseline model to measure initial performance, train initial machine learning models on transaction history. So we want to do this performance reducing complexity and start off with a basic supervised learning model. And then we also want to test recommendations, like I mentioned, with or through A and B testing. Definitely want to experiment with different features, analyze feature importance using like the SHAP method or SHAP analysis to iterate and drop low value features, refine for better accuracy. And then we also want to monitor and test different algorithms. First, test different algorithms to evaluate the performance. And then obviously monitor and evaluate the model continuously for feedback and performance data. So next we were tasked with our machine learning system design. Um, so we wanted to choose the right design based on cloud versus edge, offline versus online learning, batch versus online predictions, and based on the machine learning decisions, I felt that the best design for my credit card travel rewards optimization project was a cloud-based design because it's scalable. The recommendation system can process large data sets, and cloud computing ensures efficient scaling. So next, wanted to choose cloud-based design because we have access to real-time data. We can integrate, live travel pricing and user interactions, and then we also took into account computing power or computing necessity. So a lot of complex machine learning models require higher processing power. And so that's best handled in the cloud as well. So we wanted to do cloud versus edge. And then when it comes to offline or online learning, I felt that the offline learning would be best because, again, it kind of has it's more stable, more stability in training a recommendation model using offline learning. It ensures stability and avoids erratic suggestions. It allows for controlled updates, so the model can be retrained on a monthly basis or weekly basis to incorporate new user behaviors, and computational efficiency, like I mentioned. Um, Online learning really isn't necessary because user preferences and travel trends don't shift dramatically um, in real time. So I want to be able to have that offline learning as an option there. And then finally, um, in terms of batch versus online predictions, I felt online predictions would be best because it allows for real-time predictions for pricing and availability, which we can lead to more personalized travel suggestions because when a user browses travel options, the system fetches real-time pricing and availability before presenting final recommendations. Um, and then finally, we're tasked with identifying some potential risks that this model could have in production, some model issues and solutions here. So, even with a well-defined machine learning system, several challenges may arise in production. Some of these possible issues could include data drift. So, a source of that could be that the model is really um, reliant on historical spending and travel behavior, but, you know, seasonal trends and changing user behavior can shift over time. And also other things like economic factors, global events, regulatory compliance, or policy changes can come up in the rewards programs. So continuous monitoring and frequent retraining would be the solution for that. Another model issue that we would encounter would be model bias. So a source of this would be the impact of new or inactive users. And while the model, like I mentioned, is relying on historical data, new or inactive users may not receive the most relevant travel recommendations because of the lack of historical data for those type of users. And the model could factor or could favor, excuse me, frequent travelers and ignore real-time or first-time users. And there could be a lack of transaction data for inactive users that aren't traveling frequently or aren't using the card frequently. And then finally, we have fraudulent behavior, adversarial attacks. This could come from bots or malicious actors or industry experts that are kind of exploiting the credit card system, exploiting travel trends, spending trends, things like that. Um, and they could really exploit that by gaining unfair reward advantages. So a way to solve that solution here would be to implement anomaly detection and implementing fraud resistant logic. So that is my presentation, and thank you very much for your time.